So if you're watching this video, you're probably about to start coding. If you're a developer, then you'll understand, but most of us are actually mechanical engineers. So this tutorial will kind of walk you through C#, how it works, what it does, what are the benefits, how do you debug, and how to do a lot of things that you have not been experienced yet. If you are a CS major and you've been coding for a while, I would still recommend, highly recommend actually, you watch this video and understand how it works. This will also be a good stepping stone for understanding our development interface. So first thing I'm going to do is I'm going to remote desktop into the robot. The robot has multiple names. You can use its IP address, which can be found on the wiki, or you can use Spider 0 something. So usually it's 10.0098, it's Spider 08, or in our case it's Sky Segway. So we're going to remote desktop in. So now our remote desktop. As you can see, there's a couple things that come with the robot once you start. The first thing is you have a turn off computer. To turn off the computer, you have to press this shortcut. Same with restart computer. Do not use any other way to turn off the computer because there's a lot of things that happen and communicating with the sensor interface and the network that we use, and we want to damage it. Robot also has a couple of things, such as you have your controller form, you have your camera, which requires a timestamp for the robot, and you have a robot tester. These things seem very confusing right now because the robot is not on, but we'll see how it works at the end of it. After we understand the interface, we'll get to experience and see how these programs actually work. Okay, so a couple major things you should know. First thing is that we use Subversion. Subversion, you can see by Tortoise SVN, has a lot of options. If you look at our interface, you can see that we keep a lot of code here. Everyone's work, you can look at it. We have old projects, current projects, and a lot of the software that's developed goes into Subversion servers, which is called the Hive. If you ever hear it, it's called the Hive, and that's where somebody tells you to go to the Hive. This is where you'll find it. And you can find all sorts of things here, useful things, and great things. Now, the next thing you should know is that our main development environment is called Deasl, which stands for Development Environment for the Autonomous Systems Laboratory. We're going to be talking a lot about Deasl and a lot about your personal work folder. Your personal work folder is where you keep all your work. So, for example, I'm Ahmed. I have my personal work folder, has all my stuff. You keep a lot of things here, and there's some habits like not committing your binary files and stuff like that to keep your Subversion folder as clean as possible. Subversion also has a great benefit where you can actually keep track of what you've done. You can commit, you can update, you can check what you've done before, you put information, you log it, you can revert back to an older version of your code. And it's really, really beneficial for development and correcting so you don't lose code, and you can always have your past work saved too. Because it's a version, that means you can access it from anywhere. So if you have, you can have it on your computer, you can commit to it from your computer and update it on the robot. Everything communicates through our server. Okay, so let's see what's in Deasl first to hand, and then we'll go into looking at some C# files and how do you create your first project. Deasl. Deasl has two branches. It has stable and development. Stable is after you write a piece of algorithm and you test it, make sure it works. You go through a code review and a process where you write unit tests, and once you're ready, your code goes to stable. Stable is code that we know guarantees to work. So if somebody else is using your code or using a different code, they'll reference the code in stable because that is safe and it won't change. Development is you've just finished your code, it works very well, you want to put it into dev, start testing it in its environment, and then once you go through all the process, which is on the wiki, you'll be able to move it to stable. So it's open development. So you have a couple things here that we should talk about. The first thing is your Deasl solution. Deasl has a lot of components. Your Deasl solution will build all those components. So if you want to generate all the DLLs, you can use your Deasl solution. We have some tools for you. These tools range from different things like your Logitech controller, a map editor to create and edit maps, a robot tester. If you want to do some logging, some sensor utility, which is you can see here, which tells you which segues are good. So like right here we have our 6 scan on, our IMU is working, our GPS is working, and the segue is not, which makes sense because I haven't turned it on. So this is a lot of tools you can look into. If you're questioning about a tool, ask some people. You might be able to look at some tools and help you. We have test projects, which are projects that have been used to test some specific code, like for example TCP network test or path smoother test. These are unit tests that people develop to make sure that the code works very well. We're going to look into sensors. Sensors hold our sensors and some processing. So if we're into visual odometry, if you're looking at a hog detector, our camera server, our camera code, our bag of words detection, and our air title localizer. Most of the sensors to keep in mind also has like shortcuts because we use them often. You have your resource folder, which has a lot of the resources that you can guess. So it has something like templates, something like tab OpenGL to do the rendering that we need, a calibrator in case you're trying to calibrate something, Gaussian mapping, and the calibration files. One of the files you should pay attention to is we have a calibrated XMLs for sensor interface. These are very, very important, and these are the segues that can automatically run the template that we're about to use. If you have any question on creating it, please ask someone or look at the log for sensor module, and I'll kind of guide you on how to create these XMLs. Okay? Let's go back. Now we're looking at example codes. Again, these are codes that people have written just to give you an example about some specific things. So like grid slam, if you want to see grid slam running, GPS, air target receiver example, sensor interface template. All these things are examples that you can look at it if you're questioning something, you're not very sure how to do something, but you assume that it'll be used somewhere. Open the code and look at it and try to figure it out. Directors, I actually have never used. Core is the main class that holds everything we do. It holds all the basic functionality of Deasl. So like all your post provider default interfaces, your general structure interfaces, and kind of a good way to keep all our code very similar. So like our tree node, these are all interfaces that we implement and use in the code. So all the mathematical libraries to do all the Gaussian and vectors, and you'll be seeing these things all the time. You're always going to be referencing core, and you're always going to be using core, so you'll see it. Now it comes to components. This is all the code that kind of like we developed and we're using now. I'm going to walk through these ones and let you know what's in each one and let you understand what each one does. Communication has a lot of the communications. As you would guess, we look at something like AirTag receiver. This is a code that we run so we can receive the AirTags from the server that is getting the information and parsing the images. Litmop communicator. This allows people to communicate with Deasl and Litmop. Litmop is a major project that Hadas Kretzi works on, which allows people to speak English and convert that to code. If you're interested in it, talk to Professor Hadas and you'll learn so much more about it. Multicast messaging to send different messages, protobuf, RTK receiver for the GPS, TCP networking, which is a way that you can communicate between robots with a TCP connection. Again, some of these things you might require more information to know what they do. Just keep the words in mind and maybe Google and learn a little bit more in details about how TCP works or how these other major like protobuf work. Visual object detection runs our bag of words and hog detector, which allows you to detect different features in images and classify them. And the Weebot's communicator, which allows us to communicate with Weebot, which is a simulation. So you can run virtual worlds using Weebot, and you can communicate through Deasl. Our hardware is the Arduino, some Deasl example lidar component, our Hakuyu lidar. This allows us to communicate with the Hakuyu, our inertial IMU, which is our inertial measurement unit sensor, which is placed inside the robot. We have our Connect, which allows you to communicate with the Connect. You know what that is. We have a Logitech controller, our memory mapped camera, which is the cameras that we currently use. Pioneer, the controller, robot drive control, which is a little interface to help you drive the robot by clicking on the screen. Safe robot controller, which is a controller that allows you to send commands to the robot to move and turn, yet it will check the LiDAR and make sure that the path, you're not telling the robot to hit a wall. You should always use Safe Robot Controller if you're driving the robot with code, because sometimes your code might be wrong, and Safe Robot Controller will stop the robot before it damages anyone or itself. Segway RMP50, that's the Segway platform that we use. This allows us to communicate with the Segway itself. Such an interface, SICK LiDAR, UDP camera, and these are sensors, the hardware that we have that communicates. All this hardware code kind of read the sensors and give the information to Deasl. We have Gaussian mixture mapping, which is creating maps using Gaussian mixtures, as you would guess. We have normal mapping, which, depending on what's in it, you can look at it. It has a playfield map, which is creating maps out of polygons. It also holds stuff like your GM origin and stuff for the GPS. The new map editor is another map editor that you can use that was designed to be a little simpler than the map editor we saw in tools, and it works relatively well. Occupancy mapping, it's creating maps and different stuff using occupancy grids. So one of the most common ones is like occupancy grid 2D log odds, which is a good way to build a map with LiDAR and make sure that doesn't pick up false positives, doesn't pick up people moving. All these things get washed away using the log odds. Occupancy grid to polygon. So when you'll experience is that sometimes you have occupancy grid, sometimes you're going to go back to mapping, which is the polygon map, and switching between them. Occupancy grid to polygon allows you to go from occupancy grids and take the grids and convert those cells and those occupied cells into polygons. We're going to continue going, and we're going to look at planning. Robot needs to navigate around the field, so we have a couple planners, and I'll tell them. We have an A-star planner, and D-star planner. So these are kind of your typical graph search planners using like more advanced stuff like heuristics with Dijkstra and all sorts of things like that. D-star is the most common one that we use. It plans using an occupancy grid, so it will keep track of all the trees that it searches, and it becomes very efficient and really quick in terms of replanning. D-star becomes very inefficient when you're changing the map because at every single time it has to do from scratch. We have a Hugen planner, which plans given a Gaussian mixtures. So Hugen was a project that we worked on before, and Hugen stands for Human Robot Data Fusion, and therefore Hugen is a planner we worked on before, stands for Human Robot Data Fusion, and this can plan the robot given a Gaussian mixtures. Information planner uses Gaussian mixtures again in a very different way. Path smoother takes in a path that's rigid and turns and makes it kind of a smooth, more human-like path. Health provider kind of tracks your past movement and tries to figure out if your pose is good or not. And your VFH path follower is a vector field histogram path follower, which builds a small histogram and figures out where the robot can move. This is a very low level to avoid obstacles. So if your planner tells it to go straight, but it really cannot go there, VFH will try to move around an obstacle. It's not the most efficient way because it has no view of the map. It uses just the current LiDAR and a histogram of where it can and cannot go. So do not depend too much on avoiding obstacles using VFH. We have a lot of post fighters that we've also written over the years. We have a GPS post fighter, which you will be using, Gridline post fighter, which is using occupancy grid to do SLAM, which is simultaneous localization and mapping. So this is very good for indoors and getting really good map and pose. IMU AirTag Euler AKF post fighter, which is an Euler AKF post fighter that uses both the IMU sensors, its odometry, and uses the AR tags, which are the unique beacons that we saw earlier on the walls to detect where the robot is. We have an IMU odometry post fighter, which just uses IMU and odometry. It uses odometry to project the robot forward and the IMU to compute the turn, because IMU is really good at figuring out turn and odometry is really good at knowing when the robot stopped or moved. This post fighter is not perfect. It drifts over time, and you would expect that because you have wheel slip and a lot of other issues that we cannot see with our internal sensors. We have a Monte Carlo post fighter, which uses a Monte Carlo, which is a particle filter. and samples and uses a particle filter to figure out where the robot is. We also have a pose comparer, which compares different pose fighters, so you can handle all the different pose information and see how they compare. A pose interpolator allows you to interpolate between, if you have a timestamp, how do you interpolate the pose? It handles the angle wrapping and simple stuff like that. Self-contained pose fighter. If you're developing code that runs in multiple environments, self-contained pose fighter is really good. It wraps around a lot of the pose fighters that we're using and allows you to run different ones in different environments without having to make your code really messy. Simple pose fighter is just an odometry pose fighter. It uses odometry, which is how much the wheels have turned, to compute where the robot is. We have a UKF pose fighter, which is a UKF instead of an EKF. And we have a Vicon pose fighter, which is our most reliable pose fighter and uses the Vicon system. Dynamic motion detector. So we have a lot of sensor processing. Dynamic motion detector uses LiDAR to detect motion in the environment. We have a LiDAR segmentation, which again segments LiDAR into different parts. So if you are trying to look for a specific shape, you can use a LiDAR segmentation to split the LiDAR into different smaller segments and look at those segments independently. I don't know what this one is. Scan matching 2D PCL is it's scan matching, which compares two scans to figure out how much are removed, and this one does PCL as its technique. Sensor module is a big class that kind of wraps around our sensors, allows us to communicate with sensors much nicer and cleaner. Sensor syncing allows us to sync sensors because you might want to be comparing your camera and your LiDAR, and you want them to the timestamps to be synced, so you can use sensor syncing to sync that. It'll give you the perfect pose with the right sensor. Synced LiDAR pose fighter that syncs the LiDAR and the pose, and it gives you the pose. It gives you a pose and LiDAR at the same time. If you want to do any good mapping, it's useful to sync your LiDAR and pose. And target tracking helps you track targets, as the name says. Common rendables is where we keep all our rendables. It's kind of how we display things to the user, and this is where you'll be seeing using a lot of common rendables. And they go user controls. These are controls that develop that we'll be putting in, like our simple OpenGL controller and controllers like this that we'll be using in our class that you'll be creating with me. Utilities finally has a bunch of other utilities that you can be used, such as logging, particle filter, GMM smoother, Gaussians, airtight simulator, single point filter, unsafe matrix. These things are a little more complex. You can read about them and figure out what they do and understand it. So now we walked through the entire Deasl. Now you understand kind of what the environment is, what code we have available for you, and now let's look into how to use this code and how we start developing, and a little bit more about C# and what can it do and what's good for it.